In this lecture, we will discuss about the stereochemistry for SN1 and SN2 mechanism. For that stereochemistry, first we have to discuss some basic terms used in stereochemistry. These basic terms are first one is chiral carbon, okay. Second one is an enantiomer. Third is diastereomer. Fourth is meso. Fifth is about the then meso, and then is here racemic mixture. इंटरनल कंपनसेशन उसमें आ जाएगा. एनेंशियोमर में आगे जो इस चैप्टर के लिए इम्पोर्टेंट है, दैट इज डेक्स्ट्रोरोटेटरी. इसको डी लिखते हैं और इसको प्लस लिखते हैं. सेकंड इज लियोरोटेटरी, जिसको एल लिखेंगे या जिसको माइनस लिखेंगे. ओके. Meso compounds and racemic mixture are optically inactive. These compounds, dextro and leo, they are optically active. Optically active means they rotate the plane polarized light either towards left, towards right, or left. If they rotate the plane polarized light towards right side, that is called dextrorotatory, and if it rotates the plane polarized light toward left side, that is called liorotatory. That all we will discuss in detail. So after understanding these concepts, these basic terms, we will apply these terms to SN1 and SN2 mechanism and see what is the basic difference stereochemically, how they are different. First is like chiral carbon. So if we talk about the chiral carbon, in general chiral carbon is also called you can say asymmetric carbon. Or you can say the stereocenter. So chiral carbon is a carbon to which 4 different atoms or group of atoms are attached. Like C, A, B, X, Y. So 4 different groups are attached. So now this carbon is a chiral carbon. It is represented by star, putting star on it. Okay. Say in Fisher projection, we will represent it like in a cross form. If here we have a hydrogen, here we have a OH, here we have a Cl, here we have a CH3. See, 4 different groups are attached to which carbon? This carbon. So this carbon is your chiral carbon. Chiral carbon is the basic condition for the compound to be optically active. This is asymmetric because this cannot be symmetric if 4 different groups are attached to इसकी symmetry तो हो ही नहीं सकती. That's why it is called asymmetric. And why it's called stereocenter? Because due to this center, stereochemistry generate in the molecule. This is responsible for the stereochemistry of the molecule. That's why this is called the stereocenter. Now, this molecule, which has 4 different groups attached, has a capacity to rotate the plane polarized light towards right direction or towards left direction. This molecule exists in a 2 form. Whether if we draw the mirror image of this, so you will get compound like this. So these 2 mirror image which are non-superimposable, है ना? अब देखिए ये दोनों जो mirror image आपको नजर आ रहे हैं, these 2 mirror image, they are enantiomers. They are enantiomers. One is called D, other is called L. Okay, this is a pair of enantiomer. So how we can define the enantiomer? Non-superimposable mirror image of each other. Non-superimposable mirror image of each other are called enantiomers. What is the meaning of non-superimposable? First understand what is superimposable. Suppose we have a word A and here we put a mirror. This is your mirror. How it will look like a mirror? It look like just like A. So now when you put this A into this, it will completely fit onto it. This is called superimposable. Next we have a O. How it look like in the mirror is like O. When you put this O onto this O, it will completely fit. That is called superimposable. Okay. See, one more word. Suppose we have a T. It will look like T. So you put this T on this T, it will completely fit. It is called superimposable. Now, if I write here, say R, how it will look like in the mirrors? Look like this. It will not. If you put this R and put into it, it will not be completely fit. It is called non-superimposable. Say, suppose we have a P. It will look like this. So you could just take out this P and put into it. It will not be completely fit. So these 3 are superimposable. And these 2 are non-superimposable. Now see carefully what is the difference between these superimposable and non-superimposable. Superimposable has a plane of symmetry. You can cut the molecule A into 2 equal halves. You can cut the O into 2 equal halves. You can cut the T into 2 equal halves. There is a plane of symmetry. But see R and P. You can't cut R into 2 equal halves from any angle, from any side. Because they are asymmetric. There is no plane of symmetry. When there is no plane of symmetry, that molecule is asymmetric. And when that molecule is asymmetric, that will act as an optically active compound. So that's why the word asymmetric is there. So this compound, you can't cut it into 2 equal halves from any side. This is asymmetric. And it has a chiral carbon, so this compound can rotate the plane polarized light. What is the meaning of rotate? See, the optical activity determine करने के लिए we have an instrument that is called a polarimeter. Instrument to find optical rotation. Say this is your normal light. This is normal light. You can say ordinary light. Propagating in 3 dimensions. Just pass it through the prism or some grating. You will get a monochromatic light. This is monochromatic. Monochromatic light, or you can say it's plane polarized light, which propagate only in 1 dimension, in 1 plane, okay, either in x-axis or y-axis. So this is propagating in 3 planes, x, y, z, and it passing through the prism. Okay, it will become a plane polarized, means now it's moving in a 1 plane, like this, moving like this. Now pass this light through a solution. There is a compound solution which is optically active. Okay, so when you pass this, it must go like this if the solution is optically inactive, but it will rotate in this direction or it will rotate in this direction. You can say it will rotate like this or it will rotate like this. This is ऐसे थी पहले, अब ऐसे हो गई. Rotates toward left. पहले कैसा था ये? ऐसा था. ये पहले कैसा था? Like this. अब किस साइड रोटेट हो गया ये? Rotates towards right. Either towards right or towards left. It's either it's moving like this, it's rotated like this, or it rotates like this. So 2 directions are possible. This angle to which it is rotated, this angle theta or this angle theta, this is called optical rotation. If your polarimeter gives the values, so this is called a D or it's a plus. It's called, sorry, it's toward left, it's called L or minus sign. It is D or plus sign. If your value comes out to be, polarimeter tells you that it is 11.2 degree. If plus sign is there, it means your compound is dextrorotatory. If suppose the result comes out to be 90.0 degree, minus sign is there, it means your compound is leorotatory. Okay. From this sign, we can easily come to know that whether the compound is dextrorotatory or leorotatory. So this pair of compound is called enantiomers. So enantiomers are nothing but are the non-superimposable mirror images. Like these two are the enantiomers. One is dextro, second is leo. They are only differ towards the behavior of light. Otherwise, both are same. These enantiomers are same. They have the same molecular formula. They have the same physical properties. They have the same chemical properties. How they are different? They are different as point of view of their behavior towards the light. इनका जो light के against behavior है, that is different. Otherwise, everything is same. Their physical property, their chemical property, their formula, everything is same, but they are differ only in their behavior towards light, plane polarized light. One will rotate the plane polarized light toward right direction, other will rotate it toward left direction. जो right की तरफ rotate करेगा उसमें उसका जो आउटकम आएगी इंस्ट्रूमेंट से, पोलैरिमीटर से, वो प्लस साइन के साथ होगी, और जो लेफ्ट की तरफ रोटेट करेगा उसकी आउटकम जो आएगी वो माइनस के साथ। उसको हम लियो रोटेटरी बोलते हैं, और डेक्स्ट्रो रोटेटरी जो राइट वाला। तो डेक्स्ट्रो एंड लियो जो है, दीज आर दी एनेंटियोमर्स। देयर आर टू टाइप्स ऑफ एनेंटियोमर्स, डेक्स्ट्रो रोटेटरी एंड लियो रोटेटरी। ओके, सो ये हो गया हमारा एनेंटियोमर्स। एनेंटियोमर्स डेक्स्ट्रो कौन सा है, लियो कौन सा है, उसके लिए आरएक्स नोटेशन होती है, वो भी नहीं हम करेंगे। उसके बाद हमारे पास आ जाता है रेसमिक मिक्सचर। फर्स्ट आई विल डू रेसमिक मिक्सचर। अगर हम डेक्स्ट्रो और लियो दोनों की इक्वल अमाउंट ले लें, से equimolar mixture of D and L. Equimolar mixture of D and L is racemic mixture. और racemic mixture को हम रिप्रेजेंट कैसे करेंगे, ऐसे ही DL और प्लस माइनस। Racemic mixture is optically inactive. Why? Due to external compensation. The dextro will cancel the effect of Leo, Leo will cancel the effect of dextro. That is called external compensation. Optically active is a property of chiral compound. Compound which have a chiral carbon, that will be optically active. Optically active means that can rotate the plane polarized light towards right or left. The compound which cannot rotate the plane polarized light is called optically inactive. The racemic mixture is optically inactive because of the equimolar amount. डेक्स्ट्रो जो है वो लाइट को राइट की तरफ रोटेट करेगा, लियो जो है वो लेफ्ट की तरफ रोटेट करेगा. व्हाट इज नेट इफेक्ट? जीरो. लाइट विल नॉट बी रोटेटेड इन एनी डायरेक्शन. Okay, so that's why it's optically inactive. The stereomer. Compounds which are not mirror image of each other. जो मिरर इमेज ही नहीं है. Or in other words, you can say the compounds which are not enantiomers are called as stereomers. The compounds which are not enantiomers are called as stereomers. जो enantiomers नहीं है वो diastereomers है. और ये compound जो है ये optically active भी हो सकते हैं. Okay. तीसरी जो टर्म इससे मिलती आती है वो है हमारा meso compound. यहाँ पे मैं अब एग्जांपल दूंगा तीनों की. meso compound होते हैं compounds which are optically inactive in spite of presence of chiral carbon. Chiral carbon होने के बावजूद भी these compounds are optically inactive. Why? Suppose we have this compound. There are two chiral carbons in this compound. This is first, this is second. But compound is optically inactive. Why? Because there is a plane of symmetry. Due to plane of symmetry, as you can see, if you put mirror here, one half of the molecule is mirror image of the other half. If this carbon rotates the plane polarized light toward right side, this carbon rotates the plane polarized light toward left side. What is the net effect? Is zero, just like racemic mixture. But here you can say why they are optically inactive. You can say this is due to internal compensation. अब कोई बाहर से नहीं है, ये अंदर से ही half of the molecule cancelling the effect of other half. That is the difference between the external compensation and the internal compensation. External compensation means there are two different molecules. One is D, another is L. When you mix D and L in equal amount, equimolar amount, एक से मोल, 5 मोल उसके 5 उसके, वो दो different compounds हैं, they compensate each other. That's called external compensation. Internal means within the one molecule, like half of the molecule balancing the effect of other half. That is called internal compensation. Both are meso and racemic mixture, both are optically inactive. The reason is different. Optically active, that racemic mixture is optically inactive because of external compensation, and meso compounds are optically inactive because of internal compensation. So next is one example I am taking. Now suppose we have this compound. Tartaric acid actually. It having two chiral carbon. Isomers, optical isomers total, that is represented by a formula 2 raised power n. What is n here? Number of chiral carbon. What is n here? Number of chiral carbon. Here the chiral carbons are 2. It means optical isomers will be 4. So let's draw the structure of these 4 isomers. This is first one. Take its mirror image. And you will get H here, OH here. Okay, OH here, H here. This is another. Third one is, I'm drawing here. Its mirror image. Here is 2 chiral, here is also, here are 2 chiral. So this is your structure number 1, this is your structure number 2, this is your 3, and this is 4. Now, from these 4 structures, which are enantiomers? Enantiomers which are non-superimposable each other. 1, 2, they are enantiomers. 1, 2, 3 and 4, they are also non-superimposable. 3, 4, 2 pairs. 1 and 3, whether they are enantiomers? No, they are not the mirror image of each other. 1 and 4, they are not the mirror image of each other. 2 and 3, they are not the mirror image of each other. Which are not mirror image of each other are called diastereomers. So which are diastereomers out of these? 1, 3, 1, 4, 2, 3, 2 and 4. 4 pairs. 4 pairs are there which are diastereomers. Which are meso? 3 and 4. These are meso. In this way you can distinguish enantiomer, diastereomer and meso compounds. Okay. Now these are the basic terms of stereochemistry. Next we will discuss and we will apply these basic terms to SN1 and SN2.